Hello everybody, this is Coach Raza here. In this video we go ahead and go over scale models and a few examples to go ahead and hit it off with. Now a scale model is ideally when you use a proportion and trying to look for a missing measure in a particular situation. And sometimes when you think about scale models you probably see them like in race cars. Like if you have a little NASCAR a vehicle like a little Ford Mustang where your little brother probably plays, your little sister plays. And it's actually a scale model of a larger vehicle that you may see in real life. So that's where you see scale models, or maybe when you see a scale model of an airplane in Hobby Lobby, and then you go actually see like an actual airplane that you see out in the airport. So in this video, we'll go ahead and see how to set up certain problems. I'll see if I can change the event numbers on here so we can look a little bit more, a little bit more different. So let's say Maria is, we're going to go ahead and make it up. Let's say she is 6 feet, 6 feet tall. And to find the height of a flagpole, she measured her shadow to be, we'll say 2 feet, 2 feet. And the pole's shadow to be, we're going to go and say 12 feet. What is the height of the flagpole? So in this situation, we're going to go and measure what height she is. So she's currently at 6 feet, okay, because it's her height. Her shadow happens to be 2 feet, so this is 2 feet. And the pole shadow happens to be 12 feet. Now, if we're looking for the height happens to be right here. So that's my H. So looking at the proportion, I can ideally set up. We want to go ahead and have our height, and let's go with our shadow here. So that's going to be our two quantities we want to measure. So we don't know what the height is. And then the shadow happens to be 12. This is for the pole. And this is for Maria. So she happened to be 6/2. And so there you go. So now that's your proportion. One thing we can do is that we can cross multiply now. We have 6 times 12. And then 2 times H, which is 72, which is 2H. Divide by 2. And then the height will go be 36 in this case. So it'll be 36 feet. So be careful because I changed the values on here, so it's not going to ideally be 36 feet. So just make sure you follow along. Alrighty, so next one. Let's go with number 2. Carla is designing a new basketball court at Springwoods High School. She is drawing a scale model of the court on an index card with the width of 3 inches. So let's go and change that. Let's go and change it with the width of 5 inches and the length of 8 inches. Okay. And if I know my information already, so this is my width, which is 8 and 5, I want to go ahead and plug those in so my width is going to be 5. Oh, let me just go back. My width will go ahead and be 5. My length will go ahead and be 8. So then if the basketball court must have a width of 54.6 meters, what is the actual length? So let's go ahead and change that value as well. So we're going to change this value here. And we're going to go ahead and change it to, let's see, what was it? 56.4. Let's go ahead and change it to 58.6. Okay, just changing the value up. So that's the length. Okay, so I know this was measured in inches. Okay, I know this was measured in inches, and this was measured in meters. Okay, so we're going to go ahead and keep our measurements the same, ideally, by just simply keeping them in the same ratio. So 58.6, and then I don't know what the actual length is. Oh, that was the 58.6, and this is going to be my X from here. So then we want to go ahead and just set this up. Now we had width and then length. Okay. And then we have index card. And then we have the actual court. Okay. So do you notice how I tried making it into a box, almost like a box, but like where it's nice and like a Punnett square. So we know where all the information comes from. So my index card happens to be 5, and then my length happens to be 8. and then my meters happens to be 58.6 over, and then I don't know my actual length, so I'm calling it X. So these are measured in inches, which is fine. This is measured in meters, which is also fine. So as long as you keep them all together, you'll be okay. So we're going to go and set this up now. Solve for X. So you can cross multiply 5 times X. And then you have 8 times 58.6. So you have 5X. So when you go ahead and multiply it, let me just go ahead and use something else here. So 58.6 times 8 gives you 468.8. Okay, and then now I'm going to take that value and I'm going to go ahead and divide it by the 5. Divide by 5. And then you'll get 93.76. And don't forget, it says it's in meters. Meters. So there you go. Okay? So ideally, these are some examples on how to set up the proportion for a scale model. A lot of different problems to go and work with, but just make sure you go ahead and specify what you're working with, and then just make sure you set it up correctly. And then, so make sure you set up what your two quantities are, and what are the two objects that you are comparing. What are the two quantities that we're looking at, and what are the two objects that we are comparing. Okay? Alrighty, well, tune into the next video.